In last week's video, I talked about the carbon tax that Prime Minister Trudeau and his Liberal Party imposed on a number of provinces across Canada, including my home province of New Brunswick. And in response to that video, I received a comment from a lady who said that she was doing her part to save the earth by buying a battery-powered vehicle. And while I'm delighted for her, she's saving a little bit on gas, I suggest that it's not a solution for everyone. And there's a reason why. There's something that I would call the battery-powered car dilemma. It's a question that I want to pose to those watching that think that battery-powered cars are the solution to all our troubles. And I don't know of anybody that's ever raised this as an issue, and I don't know the answer to it. Now, before I go on to pose this dilemma, I want to clear something up. I'm afraid some of you may think I'm a tree-hugging hippie, because in the last video I made the comment, I hope this carbon tax works. I want to save my reputation. I'm not a tree-hugging hippie. I don't believe that CO2 is a pollutant, and I don't believe it's damaging our environment. And I don't believe that global warming is a thing that we should be concerned about. The reason I said I hope the carbon tax works is for two reasons. First, I live in an industrialized city, and I'm not so concerned about CO2 going into the air as much as I am about the black stuff that goes up and then falls down and lays on top of everything. I'd rather not breathe that in. So if a side effect of this carbon tax, which I think will be a waste of money, if a side effect is that businesses will clean up their act and burn cleaner fuel, my lungs will be happy for it. And the second reason I said I hope it works is if the government's going to take money from my pocket with the stated goal of accomplishing X, even though I don't agree that X needs to be done, at least do what you say you're going to do so I don't believe you're completely incompetent. Now that that's cleared up, let's move on to the point of my video. So if you're out there today and you think the solution to saving this earth is for all of us to drive a battery-powered car, I've got a problem or a dilemma that you need to solve. Now in order to explain this problem to you effectively, I need to first teach you a little bit about how a barrel of oil is refined. So I have behind me on the board a representation of a barrel of oil. Now keep in mind that oil doesn't actually show up at refineries in metal barrels. Maybe 150 years ago they did in the backs of a horse-drawn carriage. Maybe barrels were used back then. But when you hear the word a barrel of oil today, it's really a unit of measure. So one barrel of oil equals 42 US gallons or 159 liters. But I'm representing it with a barrel of oil because it's going to help me walk through the refining process for you. Now I'm only going to describe refining in the simplest terms. That's something that a topping refinery would do, which is essentially introduce heat, cause the barrel of oil to boil, and as it reaches different temperatures, different products boil off, condense, and then run down into separate container vessels for sale as different products. So let me talk through how that happens. So if you start boiling this barrel of oil at 29 degrees Celsius, what's called LPGs, liquid petroleum gases, propanes and butanes, start boiling off the barrel of oil. And that accounts for about 4% of a barrel of oil, the propane and butanes that come off. Now, if you continue to increase the temperature, at 160 degrees, you start getting what's called naphtha. So 160 degrees Celsius, you get naphtha. Now naphtha with a little more processing becomes gasoline. So all the different grades of gasoline you can buy at a gas station comes from this cut of a barrel of oil called naphtha, and it's boiled off at 160 degrees Celsius. So we'll call it gas. And that accounts for about 30% of a barrel of oil. Every oil has a different signature or distillation curve, but I'm kind of talking generically. So that's about 30% of a barrel of oil is gasoline. Now if you raise the temperature a little more to 320 degrees Celsius, you get distillates. So in your distillates pool, you have heating oil, you have diesel fuel for on-road trucks, so diesel, you have jet fuel, you have kerosene, and the distillates account for about 34% of a barrel of oil, generally speaking. Now when you get to this point in the crude oil refining process, you're left with some really heavy black sludge called residual or called black oil. And that's what you call the bottom part of the barrel. Now if you crank the heat up on the residual to about 600 degrees Celsius, You start breaking that residual down into products like bunker fuel. Now, bunker is what ships would burn or certain mills and factories would burn. It's a very heavy, dirty oil called bunker. And you also get asphalt. So it's the liquid that's mixed with stone and laid down in roads as pavement. You get asphalt. And then eventually you're left with a black sticky stuff. Call it slurry. It's really a throwaway product. Sometimes it's sold and it's blended into bunker fuel and can dilute it so it actually can be burned, but it's pretty much a residual throwaway product. So that's how refining works. You increase the temperature, your light gases boil off first, your propanes and butanes. Then naphthas or gases come off, then distillates, and then you keep heating it up and you get this residual oil, and that represents about 32% of a barrel of oil. So that's the breakdown of a barrel of oil once it's refined. So now that I've taught you a little bit about how the refining process works, let's talk about battery-powered cars. Now, what does a battery-powered car need in order to operate? It needs a battery. It needs tires. And it needs roads to drive on. Do you know what batteries, tires, and roads all have in common? They all need residual fuel from the bottom of a barrel of oil. Batteries and tires contain what's called a product called carbon black. Carbon black is produced by taking heavy residual oil from the bottom of the barrel, burning it, and reducing it to a black powder. That black powder is conductive for electricity purposes and makes highly efficient lithium-ion batteries. So it's used in battery technology for battery-powered cars. It's also used in the rubber tires that a car needs to drive. And roads, we all know, are made from asphalt. You take some liquid goo from the bottom of the barrel of oil, you mix it with stone, and you pave a road. Now here's the dilemma. If you need products for your battery-powered car that come from the last step in the refining process, remember you heat it up, and as you heat it up, all these other products come off first, then you get down to your carbon black and your asphalt. What are you going to do with all the gasoline and diesel that's produced in the refining process if everyone's driving a smart car or a battery-powered car? Now, to put a finer point on this, consider this. In order to pave 1 mile of road, a 2-lane road, 1 mile, you need 850 barrels of asphalt. Asphalt makes up, it's part of this 32%, it's about 1/3 of that 32%, so it's about 10% of a barrel of oil. If you need to get 850 barrels of asphalt, and if it's 10% of a barrel, that means you have to refine 8,500 barrels of crude oil. And if you're going to refine 8,500 barrels of crude oil, you're going to end up with 6,290 barrels of gas and diesel. To put that in terms that you understand, for every mile of road that you need to pave, you're going to produce 246,000 gallons of gas and diesel, or 1 million liters. That's just 1 mile of road. What if you're going to pave 100 miles of road, which isn't unusual? They pave long stretches of road all the time. That'll be 100 million liters of gas and diesel that are now produced that have no use because, in theory, we're all driving battery-powered cars now. What are you going to do with all that? Burn it into the atmosphere? That kind of defeats the purpose, doesn't it? Are you going to store it in tanks? Not enough tanks in the world to store that much gasoline and diesel in the run of a month even, a month of production. They'd fill up, overflow. Are you going to pour it into the ground? Probably not a good idea. So please don't insist that I adopt battery-powered vehicle technology until you can tell me what we're going to do with all that useless gas and diesel that's produced so that you can drive your battery-powered vehicle on a paved road.